Okay, so it's week 8. 3 classes left after this. I don't know if this last weekend's quiz, maybe the week before, because there were only 10 people that wrote the quiz this weekend. If that scared people away, and they're like, hell no, I'm not doing this. I'm getting into squirry stuff. I'm not doing this anymore. This is bullshit. Or maybe people have discovered how bad JPA can go wrong. But it shouldn't. If you do this course, it should prepare you. It should prepare you to not make mistakes that we see a lot of people make in production when it comes to JPA and Hibernate. And it's not just the Java thing, it's like any language that's got these RMs, people very, very much abuse them. Okay, so only 10 people wrote this weekend. So it's going down from a high of, I think, 21. I think this is the least amount of people that's written 10. Average is 67. I think that's passing. It's passed with 68, 64, 65, somewhere in the 60s. 2 people still got 100%, so we've still had people getting 100% every week.
Maybe they're cheating because they have the mock exam, so hopefully they're not cheating.
You know, I mean...
Because one of them went both.
No. Went both, did he write? Don't seem there.
When both you listening, did you write? Unmute you.
No, he didn't. He didn't write. But it looks like he got married. I think that's why he's been away for 5 weeks.
Not good enough.
So if you're listening, congratulations, Wemba. I think you got married. Because I think somebody in the Pretoria office that I'm friends with on Facebook liked a picture and it looked like Wembo that was getting married. So congrats. Okay, so looking at the bottom two, it's not like there was any question that everybody got wrong. You know, like the bottom 2 questions is at 50%, so it's not too bad. But then it was like a bunch on 60%. So I'm just doing the bottom 2 again. So that's question 6 and 7. So 6 was one looking at some of the aggregate functions. So that's why I sort of said you maybe should read the JPQL chapter just a little bit ahead. So these classes I do give hints, not obvious hints. Not like this is going to be in the quiz, or little asterisks. It's going to be in the quiz, but I guess this one you wouldn't have picked up just from that chapter 7, so you had to read chapter 8 about it. So this is sort of looking at which ones are the correct uses of aggregate functions. So out of this one, so I've usually seen like in exams or the quizzes or something, if there's like 6 options or 5 options and like 4 of them or like a huge number of them are the ones you have to pick, it's usually easier to pick the incorrect ones. So always like depending if there's 6 and you have to get 2 correct ones, it's easy to get the 2 correct ones. If there's 6 and you have to get 4 correct ones, it's easier to get the incorrect ones. Sort of. So sometimes you can approach it that way as well. So this is one of those where 4 of them are wrong, so 2 of them are incorrect. So 4 of them are correct.
Move on.
Yeah, so it's almost going and picking the incorrect ones will really make this easier. The first one is the any. Any isn't an aggregate function. It's actually used for subqueries. So it's the any, sum, and all. So that one's already gone. So you can really kick that one off. So that gives you 5 out of 4 that you have to go and pick. The other one is that we haven't covered yet, but this is this constructor one, where you can sort of construct non-entities and bring them back or create new entities. So you can't use the aggregates in there because the one thing that you should have known here is that an average brings back a double, not an integer. So that's why this is incorrect. So if it was a new double, this would have worked, but it's a new integer and average brings back a double. So you should pick that up if you read a chapter ahead. So that's incorrect, so it means those ones are the correct ones. So this is one of those where you need to just know the rules. But there isn't that many aggregate functions: count, average, size, max, min, and so on. So it's, and then the other one was question 7, and this is just one of those. You just need to know how queries work. So one of the main things from last week's session was queries and the type query interface, and knowing how those works and what they're used for. So this one is one of those where there's 6 and there's 3, so you can go either way. But I generally find it's easier to do the ones which are correct when it's this way. So, so what do you use the query interface for? So one thing is to control the query execution. Yeah, let's say you execute it. So do you get result or get single result list? Get single result or get result list. The other is it can retrieve only through the entity manager. That's once again correct. So the entity manager is like from week 1, that's week 2. That's sort of the door or the entrance into your persistent context. So it's the only way you can interact with it. So if you want to execute a query, it has to be against a persistent context. The only way to do that is for the entity manager. So that's the other one that's correct. API, the query API is used only for dynamic queries. Queries, no, it can be static as well. So you don't have to dynamically go and create that. So that's nonsense. Query API supports name parameter binding, but it's not support pagination control. It does. There's like a whole little section it does there. We used to execute SQL queries that we saw last week. You can do the JPQL or normal SQL queries. That's correct. The query instance is created by the persistence provider for each named query. No, it doesn't. You still have to go and say, named query, go and execute it. It might cache it for you, but you still have to go and actually say, create query and then pass in your named query. So those are the 3 ones that are correct. So you just have to know this. When it says that whenever you see a query question, you see the query interface, really start going through, what does that mean? How does it grade it? What does it allow to do there? How do I get results from it? What interface is involved? What exceptions can there be? But it's always like those type of questions where they're sort of study questions. You can work this out. You have to know that. Those are the type of things that you just get from having actually gone through the work, reviewed it, gone through the specification, actually reviewed the thing, played around with it a bit. Doesn't help much, but it's sort of one of those, you just have to study it to know it. Okay, yay, we've got 2 people. All right, so this week, going on with queries, so this week and next week, looking at queries. So this week we're looking at the JPQL, or the Java Persistence API Query Language. And see now it already says boo. But, so we have to examine this language, then look at select, update, and delete statements. So the select, when I say select, it's actually a lot more than select. I think select is pretty much everything else except update and delete. Yeah, so it's your where and from. So let's start out with select. So select is your simplest query you can do. And the structure of your JPQL and normal SQL queries are pretty much the same. You select from something, so we're going to select something, and we're going to select it from somewhere, and then you can have like some conditions, some sort of ordering and stuff like that around it. But that pretty much, although this is a JPQL syntax, this looks exactly like normal SQL. The main difference is that in normal SQL we're going to select from tables, but like we saw with JPQL we're actually going to select from the entity. So these are the entities, your classes, that are in your source code. So if you've got an employee class, that's going to be your employee entity you're going to be selecting from. So if there's an employee table, maybe EMP, something like we saw last week, that's a normal SQL. So you're never going to select from it like that. And the other thing is that instead of selecting selecting splat or wildcard, I used to like use splat, the star character. It looks like a splat, like something like a little full stop you squished. It's a splat. But nobody, I don't know, I picked it up. Like in my younger days, when I started learning SQL, one of the senior devs I worked with called it a splat. It's just always stuck with me. Splat, like splat from whatever. So maybe there might be a question about that. So remember to use splat. I want to bring it back. So in any case, so you're going to, so instead of selecting splat from, you're actually going to use this little E at the end of your entity, which is called an identification variable. You can select from that. And then like the little boo Rory gave there is when you really want to bite yourself in the butt with Hibernate or any JPI, it's these JPQL SQL, because it's sort of left up to the provider how the provider is going to generate the SQL. And if you don't know how it generates it, and you're just going to assume that this provider is going to generate beautiful SQL for you, you're going to be burnt.
Maybe loading the whole database.
Yeah, you're gonna be burned. So one thing that usually helps is to sort of actually switching on the logging in your dev environment, and actually seeing what SQL gets generated from there. And I think stored procedures aren't supported. There's only 2.1 supports stored procedures, actually calling stored procedures directly. I think it's 2.1. So one of the ways that we sometimes also get past this ORM thing is actually go and write a stored procedure and then calling the stored procedure, because then the JPQ is just going to execute the stored procedure. It's not going to generate its own one.
And when it breaks, the DBAs are responsible.
Yeah, then you can sort of, hey, DBAs, stored procedures will work. And that's only available in 2.1. So if you're going to be able to use 2.1, use it. Probably use stored procedures. But JPQL is there. They're going to ask questions about it in the exam, and you're going to need to know it, and know it in detail, know it intimately, know the nakedness of it. You need to be able to walk around naked with JPQL. That sort of confidence, that's the sort of relationship you're going to have with it to write exam about it. Because they're going to ask a lot of funny questions and try and trick you up with this, because normal JPQL isn't difficult, but when you have to think in this JPQL terms, it's a bit different from SQL, and there's a lot of shorthand that you can use, and you're going to need to know that. So first off, when we're doing a select, we're going to select some data out of there. Just wanted to remember that it's not in this, but from last week, is you have to, any data you bring back has to be an entity. So it can't be a non-entity. 2.1, it can be a non-entity. You can actually just do a normal, it can be a normal class, but in JPA 2, it has to be an entity that comes back, or it can be an integer or a string or a double or a tuple as well. So the normal ways you can either bring back we can use what they call the path expression. That's that dot operator notation. So if you're setting from something like employee with an identification variable of E, it'll be e.name or e.salary. So that's the path they talk about. You can select multiples of them, separated with commas, the same way you can do normal SQL, different fields, so e.name, e.salary. And then they've got, for some reason, they've got some names for the different ways, things you can select. So they've got a single valid association path, and that'll be, and I've got some SQL, before I go on that, I've got some demos here for that. And I've based the demo sort of from the JPA 2 book. In this chapter, I've got this little ERD diagram of employee and departments and then phone numbers and stuff. So I've based the demo on this. So a single association will be something where an employee can belong to one department. So if you're actually going to return that department, that's a single association. The other one is a collection value association, and that's something like phone numbers, where an employee can have multiple phone numbers. You want to bring back that list of phone numbers. So that'll be the phone numbers. In a normal state field, what they call a state field is something if you just want to bring back the name or the salary field on there. So if we go and look at what that looks like in code, here to presentation mode. Looks something like this. So looking at a single value association, when we do a select, see we've got an employee, I'm selecting a department, which is a relationship or association of the employee. It's coming back. Our state field is just selecting a single field on there. And then you can also have a collection like the list of phone numbers. So you can, a list of projects like I've got here. You can also go and chain these things. You can also have like a bunch of things. So from department, you can actually go e.department.name. So you can chain it up like that. The only rule here is I can't go e.department.employees here. It needs to be a single value association that chains next. So I can't go employees there. And then it's going to say, hey, I don't know what's going to return you. So whenever you're doing any chaining like that, it has to be single valid and goes from left to right. So if you kind of see what that looks like when it just executes. So you can see with a single value association, we're returning a department. Damn you. Department, let's just bring it back. Our state field, we're just returning the names there of all the employees. And our collections, we're actually returning all the projects that every employee belongs to or works on. The other thing you can also bring back is your entities. So if you just do with the returning like your identification variable or any joint you've got there, so your department or something like that. And you can also use distinct, like a normal singular, if you want to cut out any duplicates. So if for whatever reason you want to get all the departments, but you're doing it by the employee entity, but you only want the distinct departments, you can select distinct from there. Why you don't just go and select it from the departments? Well, maybe if you just want departments with employees in there.
Not use term here, so everyone just would put distinct everything, not caring how much it's going to cost.
Yeah, so distinct, that does cost you, because it still gets everything before it distincts it in the database. One of the caveats here with the entities, if you bring it back, if it's an embeddable object, you bring it back directly. So last week, something like an address, which is an embeddable object inside the employee. If you bring just the address back as you select e.address, you just bring back the embeddable object, it's not managed. Remember that for it to be managed, it has to have an identity, and embeddable objects don't have an identity. So that's the only little caveat there. So next, looking at the from clause. The main thing is the from clause, we're going to select from an entity and then give it an identification variable. And you can also have your join declarations there. And the only sort of rule there is there needs to be at least one identification variable defined in the from clause. You can also have a little extra optional notation. So instead of saying employee E, you can say employee as E. I think you've seen this in SQL as well, where you can alias fields and tables, but nobody ever says as, because that's just as. No, it's not. I thought it would be like a toilet joke, but it wasn't.
No, I think you need an R in there.
R's. That might be like an Irish joke. No, okay. Let's just leave it there. And then you've got your joins. So joins are interesting. In normal SQL, when you do a join, you sort of explicitly say it, and all except when you're doing Cartesian joins, Cartesian products. So joins, inner and outer joins, Cartesian products work in JPQL works exactly the same as they do in normal SQL. But there's sort of 4 ways that joins will happen in JPQL. So the one is if you've got 2 or more range variable declarations in your from clause. So that's if you do a select. It'd be easier if I just go down to where we do that. If you do like a select from e.employee, e.department, because you've got 2 there, we don't actually say the word join or anything. We're not doing anything with e, but the fact we've got 2 in there is actually going to do a join for us, and it's going to return a Cartesian product for us there. So every record from employee linked to every record from department. There are use cases for it. I think there are 2. Do any of them. If you actually use the join operator, so if you actually go and say employee.join e.department, so if you actually have the word join in there, that's going to create a join for you as well. If you've got a path expression that actually navigates across a relationship like that, that'll be something like here where we're selecting from employee E, but we're actually saying e.department, so that department is a different list of entities. So that's going to create a join for you as well. So even though we're not saying join, it's going to do an inner join for you there. And the last one, if you're doing a compare of attributes on your identification variable, so in your where clause. And that'll be something like the bottom one here, where you've, instead of doing just your e.d, where you're going to have a Cartesian product, you actually have a where, and you say sort of where my D entity is equal to my e.department entity. So if you really want to get weird, you can do it like that, instead of a join. So that'll, instead of doing a Cartesian product for you, it'll actually do a normal inner join for you on that. So those are the 4 different ways that you can join. I don't think they're going to ask you the 4 different ways, but just be aware of them. And I think the main thing you need to know is going to be an inner join or an outer join, because they'll probably ask you something like, they'll give you a list of data, and they say they want the subset of the data returned, and they'll give you a list of either queries you need to do, or a little click and drag one where you have to build up the query. You're probably going to need to know, do I need to do an inner join or an outer join? We're going to need to do a Cartesian product there, what I'm going to need to do. So from that point of view, you're going to need to know what's going to return the type of data for you. But I mean, if you know how inner joins and outer joins work, that should be fine. So for an inner join, you can use the little inner in front as well if you want to. Otherwise, you can just say join. You don't have to say inner. And you can join on collection associations, single value associations, and you also do multiple joins. So that's a normal joining on employees, joining on phones or departments. You can also do multiple joins, like an inner join on an inner join on an outer join and a left outer join, that type of stuff, or your where clause. So we've looked at those. So if I just go and run this, what it's worth, as I say, it brings back data.
Using Hibernate?
Yeah.
You switch on the SQL logging and tell you what the SQL.
Probably. I'll switch it on and put it in the on GitHub if it's switched on, so you can see it. Okay, so for the exam, you don't need to know what SQL gets generated, but just for your own sanity and knowing what happens, switch it on. Oh, there's more joins actually. So then you've got your outer joins as well. I've completely skipped over that. So if you want to do an outer join, you have to say left. So don't do right outer joins, you do left. But I mean, if you want to do right outer joins, just to switch the entities around. Never really understand. The reason I even want to do like a right join is you've got like a chain of joins and you have to have the one somewhere else. But I don't know, that's
disconnected. That they don't have reference or anything.
Yeah. So the JPA just there's left outer joins. On 2.1, you can also use your on conditional operator. On there, not on 2. So for the exam, you don't need to know it. So you can use an on as well. So because what happens is if you use a where clause as part of an outer join, it actually just creates an inner join. The where clause, because you're actually limiting your results then anyway. So it's.
On's a very old word.
Stored procedures as well. The JPA 2.1 only supports it, so it's
like cutting edge.
Yeah. And so if it works like a normal join, we just do a left join. So we do a normal join to an employee and department. It'll bring back every employee, even the employees which don't have departments on the left join. If you just do an inner join, it'll be employees that have departments. Then the one thing that's a bit different, when you did the cascading and relationships and stuff, you had the default was that your relationships were loaded eagerly. With the select and the JPQL, it's the other way around. It actually lazy loads it when you do a join. And I mean, the reason for that is when you do a join, and you're joining on department and employee, but you're only looking at, let's say, the employees, but you're joining a department. You don't necessarily want the JPQL to bring back all the departments as well. So that's why it doesn't eagerly load it. It actually lazy loads it. So it's part of optimization there. But there are circumstances where you might want to eagerly load it. Especially if you might not select in your select course, but you might not access that department or address or whatever other relationship you've got there, but later on you might want to do that. So if it's lazily loaded, it means that later on you're going to try and use it, actually it's going to do that SQL request into actually going to fetch that data. So that can also slow you down. So you might say, give me all my employees, and then 10 lines down, you actually go and do something with the departments, and then it's going to do a SQL query for all those departments every single time. Every employee, you're going to do something on the department.
Yes, spiking your database at a specific time, at a specific client, press one button.
Yeah.
Boom.
And so on. So in circumstances like that, there's a fetch keyword you can use. So you can see we do a select E from employee, and we might, although we're not doing anything with the address, this is a relationship or embeddable class. We're not doing anything for right now, but we might do something with later. We can actually say fetch it for us as well. Then what it does in the background, although it's not being returned, it's going to put it in memory for you so long, so that when you use it later, it doesn't have to do another call to the database. So this is one of those things where you don't necessarily want to go and fetch every single relationship. You need to sort of look at the use case and see what you're doing there, and then decide, listen, well, actually we want to eagerly go and fetch this. And the way that would look is just a normal join, inner join, outer join, and you just add your fetch keyword at the end. So look at the thing here, so we're actually saying get our address for their employee. If you don't do the fetch eagerly, it'll actually go and do a SQL command here every time to go and fetch that address for us. Well, it might be clever enough to go and fetch it up front for us. So once again, this is also a hint. So it's just going to do it. Next we come to the where clause. So that's where clause is used to go and filter your data out. So you don't want to bring back all employees. You might just want to bring back employees with a salary above a certain threshold. We looked at the perimeters last week, so I'm not going to cover it again. So that you can use your name to positional notation for your perimeters. One thing to remember is that with JPQL, it can be used named and positional, both are supported. When it comes to normal SQL queries, straightforward SQL, the spec only requires it to support the positional notation. So some providers do support the name notation when it comes to straightforward SQL queries. And once again, the main difference between normal JPQL and SQL is that instead of using tables and fields, we're going to use identification variables and path expressions in the where clause. So again, normal where, we can just say it's normal where, and instead of doing a table, we can use our identification variable. We can cross the entities there, we can go to a specific field on department, we can use the perimeters there, all type of stuff. So it looks like a normal select query. Then within our where clause, we can have subqueries. So subqueries are only allowed in your where and your having clauses. And with your subqueries, you can do your normal between, like, in, exists, any, all, some operators. So between, like, and in, everybody should know from SQL. Exists also in SQL. So exists, if any row gets returned, it's going to return true. If no row gets returned, it's going to return false. The any operator is if you want to go and check something. Let's just see what I've got here. So this query goes and returns all departments where the employees size, or all employees that belong to departments got employee size bigger than 5. So if any department that, if this employee belongs to any department, it returns 5. It's going to return. If you want to do something like an all, it might be return all the employees where to return departments or the employees that belong to department where all the employees have salary bigger than X amount. And the any and some are the same, so you can use any or some. I don't know why there's 2 though. Might be some legacy thing. Like I said, the important thing is that where and having is the only ones that are allowed to have subqueries. So you can't do a select. You can't have a subquery in your select. And then for when you're using collections, there's some shorthands. Once there is empty and member of. So looking at a collection here, so if you're going and saying, because the eDirect, so that's a list of employees that this employee can manage. So if there's a manager, it's going to have a bunch of people under there. So if you want to go and say, give me all the employees who are managers, who aren't managers, so where the direct is empty, you can do a query like this. So it reads a bit easier. You can have done the same type of query as the one at the top here instead of that. So it's a bit of a shorthand to go and get that out. And then member of is sort of saying, listen, does this specific record or entity, is he in that list or in that collection? So you can go and say, so I've got to find a project here. I just used whichever project's project 1. And say, going to return all the employees that work on project 1. So where project 1 is one of the members of that employee's list of projects. So it's a nice little shorthand. You could have done the same thing with a in clause as well. I think in the end, this type of JPQL anyway is going to generate this type of SQL for you. So it's just a bit of a shorthand. And I don't know, maybe I think it reads easier, or they just want it to be different. But it's not going to optimize the query at all. It's just a different way of reading it. So that sort of helps you when you're working with collections. It makes it a bit easier. And then the other thing you can also do is, because we can have inheritance between our entities, you can have some polymorphic behavior there. And this is if you, and this is sort of just introduces some operators that you've got to. The one is the type operator, and that's if you want to select a bunch of, let's say, projects like we've got here, but we only want the ones which are part of the design project subclass. You can do it where type is equal to whatever one you want. The only thing is that that type we've got there is like a normal entity, so it doesn't, it's not in single quotes, it's not a string, it's the actual entity, it's the actual type we want to have there. The other thing you can do is also you can downcast or cast it, so treat it as something. So we've got our projects here, something like the quality project has an additional field called QA rating, which is only available in your quality project. So if you do a project where your quality project is a QA rated 4, you can do a treat, so it's like a cast in there. Yeah, no, it's
someone acting ready.
Yeah, so you can say we want to select all our projects, but you only on the projects which belong to the design project. We can do where the type is equal to P. That project you can also pass in an identity, you can also pass in as a parameter as well. And if you want to cast it to something, so you can do it, say treat. I mean the same at the top, because if you go to, because the one at the top when you say type, it doesn't matter what type of inheritance strategy you use. We're using single table, or whichever the other two are, can't remember now. It's going to work the same for all of them. Table per class, a single table, table per class, something about joins. So that'll work across all of them. So if you add a single table, you'll have that discriminator field. So you could have probably used the discriminator field if you wanted to do something, but that's only if you use single table. And then you can do your treat. You can also do a select from project, so you can probably select from quality project there as well. It'll probably done in the same. But this is more if you want to do things across all your different projects, but you specifically only want quality projects for curating or for. So yeah, that's sort of weird. So I mean, you might never see this, you might never use these, but you need to know them for the exam, and they're probably going to ask them. The next one we've got is scalar expressions. So scalar usually means it returns a single value. So it can either be a literal value, a arithmetic sequence of 1 plus 1, or this field minus that field, this field times that. The function expression, so you can actually call functions on them. They've got normal apps, length, mod, size. There's a few of them. Substring. For the exam and the review, you kind of need to know which ones they are and how they work. You don't need to know their syntax, but you probably need to know how they are used and yeah, maybe their syntax. But most of these things, if you've used them in normal SQL, you know how they work. Type expressions, actually like our type little expressions here we had before, or case expressions. So we look at case now. So scalar expression you can use your select to where and your having clauses, and where did I jump to now? And that's it. So there's not much to scalar values. Like I said, main thing is that you use them in your select clauses like we've got here. You can use a substring there, or you can use a substring in your where clause, or you can use a type as well. So the other one they've also got that is your case expressions. I've actually got 4 different, which they call case expressions or case statements. So the first 2 is your normal case expressions that we've seen before, case, when, else, all that type of stuff. And they sort of mention 2 different variations of it. So the one is where you do a case and on your when you actually go and check whatever you're using or whatever you're casing against on each single when statement. Or there's one you just do it straight at the top once and then you just do a when afterwards. So there's 2 different variations of when. The top one you'll probably use if you want to check different types of fields or different fields on your case. So if instead of doing a type, you've got a different type of scalar there, so maybe an arithmetic or a function or something like that. So when x is bigger than 2, do this. When x is smaller than 2, do that type of stuff. When you're going to do the same type of scalar check on all of them, you just do it once on the case at the top there. So your case expressions, this is normal like that. So when case type is equal to that, and that solves that. Then the other one I've got is coalesce. So I'm sure you've used this in normal SQL. And that sort of brings back the first value, nominal value in the list you give there of the 2. So generally you use this for null checks. So on here we select it from department. You can say if the department name is null, rather return the ID. So something that whatever is using the data coming back from the specific query shouldn't be handling nulls or shouldn't be expecting nulls. So you'll do a coalesce for that. So you could have done the same. You could have done a case statement for this as well. So it's a shorthand for a case statement. So you could have said case d name, and then you say when null, then ID else the name. So it's sort of a shorthand for your case statement. So you can see there, I do a select here where I get the manager's name. If there is no manager name, I just return no manager as the name. So sort of a little null check case statement. And the other one that you don't find in normal SQL is null if, well, not in the SQL I've worked with before. That pretty much says if both these values in there are equal, return null. So it's whenever you have to return a null for some reason. So in the book they mention that this sort of is used to exclude results from an aggregate function. So if you're doing a count and you want to exclude certain things because aggregate functions ignore null values. I couldn't get it to work with Hibernate though. Hibernate, like this count null if, Hibernate says nope, not going to do it for you. So yeah, I don't know.
Like you said, divided, subdivided to implement this specification.
Like I said, there isn't a null if SQL statement. None that I've seen. Definitely not in DB2 or SQL Server. I don't know, I haven't worked with Oracle database that much. I don't know. Because I'm sure they had JPA before Oracle took over Java. So it's definitely, I don't think they included it for Oracle compatibility. So null if, yeah. I say sort of I couldn't even if I put count in here.
Make it challenge, eh? Make one of the guys to see if they can do it.
Let's see.
You can get null if to work.
Yeah. So if you can get null if to work, that's
Bragging rights.
Yeah. Put your photo on the presentation. No. Yeah, I don't know, I just didn't feel like figuring this out. I could have probably Googled it. I'm sure someone on Stack Overflow has had this question before. So whoever wants to go and search for this on Stack Overflow, yeah, I don't know. That's the 4 different case expressions. So I don't necessarily think they're going to ask you for this, but you're probably going to have some other scenario and they're going to ask you which SQL is going to work, or they might give some JPQL SQL that's funky and you're going to have to say, well, which ones are valid use case statements or something like that. Then last bit we've got is your order by. Like I said, that returns it ordered by whatever field you want on there. And then you can do your ascending or descending keywords. Like I say, sort of the default is ascending. And that orders it and returns an ordered list for you. So you can see we can order it by name. So if the top one, if we do an order by there, it's just going to return the employees sort of sorted ascending by their names. Otherwise, we can return them descending. I don't know, like you missed a bit of that first session at the DAC yesterday about the SQL perimeter sniffing. Because that's more stupidity. Because like the one question I asked the lady was like, but could you pick up that was a problem from the query execution plan? She was like, no, I don't know how query execution plans work. I was like, all right, yeah.
Presenting in front of 40 people, you better.
Because I mean, we've had this problem at one of the clients we work at. We had a stored proc which has an if else in there. And they have the same sort of select, but it's like if we've got this field, include it in your where clause. If you don't have this field, don't include it in your where clause. So what happens is the first time you execute that stored procedure, whichever one of those queries you hit, that's the query execution plan is going to cache for you. So it optimized for, so now you go and call it with the other else statement. It's not optimized for that, and it's shit slow. And you can see that from your query execution plan. I mean, you go your query execution plan, it's like, but why is it not using this index? And even if you just take it, and it's like, and then you know what they do is they put a recompile on there, on the store procedure. Every time it actually recompiles, so it's like, stuff you query execution plan. I'm going to read you every single time. So, I mean, if you've got any fast or things that get called a lot, that's just going to kill you. The other thing they do, there's a call in SQL Server, which you invalidate the entire crashed query execution plans on the entire freaking database, which you can set up a job to run that once an hour. It's like, what? That's not even using duct tape. That's like, oh, I've got this open wound. Let me rub mud into it. I couldn't believe it. That was like one of the worst presentations ever.
Sell the judge rather than the dike.
Yeah. I mean, the thing to fix that is don't have two different types of queries in your stored procedure. You shouldn't have that type of logic. Or if you're going to have that logic, split it up. Like have one stored procedure that calls one or the other one. So at least those stored procedures that it calls will have the query execution plan correct.
Don't even mention cataloging.
But it's so bad. All right. Anyway, so then the last thing is sort of the aggregate query. So that's when we go and group data together, and you want to see the average or the count or the maximum, minimum, sum things up, all that stuff. So everybody's used aggregate functions in queries equals before. One thing when using it with JPQL, just be aware of the type it's returning. We saw the average returns a double, so it doesn't matter if you're averaging an int or averaging a long or averaging a float, it's going to return a double. So be aware of that. Count doesn't return an int, returns a long. So just be aware of that. So in your group by clause, you're going to define your expression that you want your things aggregated by. So you're going to group by a specific field or a specific type. And the one thing with JPQL, and this is in any normal SQL, if it's in your group by clause, it has to be in your select clause. So it's not going to magically, unfortunately, don't generate a SQL for you. It's not going to put it in your select clause for you. It should actually. It's like, oh, this field's in there, just put it in there. But no, so you have to, whatever field you're going to group by, it has to be in your select clause. And that's, any normal SQL does that. And JPQ, although does do it if you going to not have a group by clause, it gets applied to the entire single results as a single group. So if you're going to say average, is going to group it as one big group, and say the average of that, or the count of that. But that's what normal SQL does anyway. They're just wording it in a way. So we're going to look at something like aggregate, so we can do stuff like getting your average salary, so that returns a double. Doing a group by, so here we're grouping by our department names. You can also group by your department, but then you have to select a department in there. So because you're grouping by department name, we have to select department name from there as well, and we can say the average salary in each department. The fact we don't do a group by it is going to say, well, the entire list of employees is one group. Then having is the other thing then. Something like usually a lot of people don't use having. Usually see that people return a list of results and then they kind of filter it again in code after they've returned it. So having gives you that sort of secondary where clause. So after everything's been grouped and put together, you can filter that list as well. So something like give me all the average salaries, but only bring me back the averages that are bigger than X amount. So you'll average having like that. And that's where you use the aggregate function again. So if we've got a department name, we get our average salaries again. We only want to bring back the departments that have a salary average bigger than 50,000. So using the average having there. So in your having, and remember having and from having and where's we can use subqueries as well. So you can also do exists or any or some in your having as well. Having is actually quite powerful. Understand? So that's it. So that's a leg demo. So I'm not going to run through this again, but I'll put this on GitHub. It's got all the different ones in there. You can also look the actual source code for the book. They've got like a huge project with like a servlet you can call that executes all different types of queries. You can use this one as well. Then the other one we need to look at is the update and delete queries. So nothing special here. Once again, the update uses the entities, not tables. Your where clause is exactly the same as the select ones. And you can update more than one thing at a time. So there's no funniness there, actually. The only thing when doing an update or delete, instead of doing a get result, we do an execute update, like from last week. So that's the only real difference. You do an execute update. It's going to return a list of updated, how many result sets, how many records were affected by that. I don't know if it's a JPQL that does it, because I know on SQL you have to switch that on. It's specific things. If you're going to call a stored procedure or SQL, it doesn't necessarily always return the amount of things that it's. Because I know for something like
you have to have like a ret. You can have remember, in the store procedure, you can have multiple returns and return multiple persons, multiple returns.
Yeah, so I actually need to go and check this. Maybe that's homework. Is there something else provider specific? Because I know like a lot of people, because this is also the one of the things when people go and write down little the utilities to update, and then they return a boolean if it's been updated or not, and they base that boolean on the fact that the amount of records that were, and then they realize, but it doesn't always return the number, and then they just always return true. And people who use it have actually go and check it. Because the problem is actually if the update doesn't work and it's important that it works, rather throw an exception. That's why they are there. It's like, oh shit, this was supposed to update, it didn't update. Not like, oh, the 0 records are updated. Okay.
Like payments, they don't go through.
But I think that's also probably comes down to an architect's type one. Do you want your data layer to be throwing exceptions? Maybe. Do you want your business layer to decide to do it or not? Well, it's happened. Probably something went wrong on the database layer there. So you want the database layer to say something went wrong, especially if you're expecting it. Then the delete, same, deleting from a specific entity. You can use your where clause, same as the select one. One thing that the delete statement does do, though, it does polymorphic deletes. So if you say delete from, yeah, if you sort of say delete from this specific entity, if there's subclasses, it'll delete those as well if they fall into your where clause.
It's actually a beautiful thing to watch, deleting the whole database. I think you did it 2 sessions ago.
Yeah.
Just cascade everything.
Yeah, so it's one thing though, if you do a delete query, it doesn't cascade. So normal, if you actually use your entity manager and do a remove, that uses a cascade. If you do a delete statement, it doesn't cascade because it's going to convert it to a normal SQL statement. And normal SQL, unless you've got your relational integrity set up to cascade, which nobody ever does, and I don't think you ever should do that, it's never going to work. So so if you do a delete from employee where salary is equal to that, so any employee, we've got phone numbers and stuff like that that's linked to it, and departments. I'm going to share here. Just comment that out. And comment that. If we run this, it's gonna wet the bed. You can see that it doesn't got foreign key violations, all type of stuff here because there's phone numbers and all the types of other things to link to it. If we did a remove and there was a cascade on our entities, it would have worked. So, and these days you don't really go and delete stuff out of a database by code. Yeah, but from your source code, if you want to clean it up, you can probably archive it. But I mean, best practice probably go and mark something as deleted, because there's always shit where
in banking you can't delete something.
No,
you can't.
Yeah, so additionally, don't go and delete stuff from source code. Don't have a press this button and deletes it. Rather have a field on there which says this is active or deleted or something. It's much safer. You won't lose data because it's one of those things where shit went wrong and you go back and you check and it's like, but this record isn't here anymore. So what actually happened? All right, so no questions. Time's almost done. So next we're going to be looking at the criteria queries, the API. That's very interesting. I think that could be difficult. That could be nasty questions if you're not used to it, because it's like I said, it doesn't feel natural using it.
Full on yourself.
So you look at chapter 9 and 6 for that for next week. So a reminder so long at the end of the month, the 30th of November, Josie Jug at Standard Bank at Rosebank.
And Tobias now is a co-organizer for the Jug.
So
he doesn't even have to say, Rory says reminder, he can say reminder.
Yeah. So it's on the 30th of November at Standard Bank and Rosebank. So it's all fancy schmancy. The new fancy schmancy. If you haven't driven past there, it's like a big glass monolith building there.
200 Rand per head.
Yeah, so they're catering for about 200 Rand per head there. So it's going to be wedding food. It's not going to be plated.
Discovery style.
It's going to be delicious, even if you just come for the food.
Please stay for the talk.
You can stay for a talk. So the talk, and the talk is about the elk stack. So it's
Camel, with the
Apache Camel. It's using, and that's the Standard Bank Group mobile. They're using that in their logs.
Which representing here is Donald's.
So Donald is sitting here, he works in that team. So they're going to be presenting on how that they work and how that uses. So I think it's, when it comes to looking at logs, and whatever makes it easier to looking at logs, because especially in the Java space, containers, you can't go and replay that. You're going to have to go and look at your logs and see what's going on. And something like Elk-Stack helps you go for it and helps you with debugging, finding problems. Because a lot of times that's the only resource you've got. If something happened in production, shit went down, things went bad, you have to fix it up. Log files are sort of the only way you can look at it. And having something like Elasticsearch to help you with that, good stuff. All right, so attendance keyword. I'm going to stop doing the attendance keyword as part of the YouTube video. So force people to get up, because I'm getting up early. And the rest of the people who are online, people who come into the office, by people I mean Donald, who come into the office, they should get the keyword. And the people, anyway, I won't do it this week. Maybe I'll do it next week. So the people on YouTube, if you're not watching this live, you might not get the attendance keyword next week. The attendance keyword for this week is JPQL. I think we've been doing the whole session, the whole hour so far. Sandile, you just joined for the keyword, didn't you? Busted, kinda. I can see in the group chat you only joined just now. I'll have a talk to you at that after when I get there. All right. Okay. Oh, and then the other thing is, people are in Joburg. The 15th of December is the developer user group at Microsoft. They're having their Geek of 2015 session. So that's quite cool. It's like a pub style quiz, lots of prizes. Actually give away like a shitload of prizes. I think like for the categories, the price is worth about $1,000. So it might not be a single prize, but the total prize is about worth $1,000. Then there's little spot prizes, which are about $300 a prize. So it's quite lekker. So 15th of December, so 2 days, 30th of December, Standard Bank, Josie Joke, Elk-Stack, 30th of November, and 15th of December is the Doug. Are we doing?
Yeah, we're doing it 6th or 7th of December. Different dates at Intellect. They're going to do the coding challenge.
Yeah. So for Josie Joke, last session of the year, we usually do like a little coding challenge. We did RoboCode last year.
Yeah, we're going to do their Space Invaders.
So it's actually quite fun.
Very late.
Yeah. So it's nice playing around. And I don't know. I think the prize usually is JetBrains license. All right. Cheers. Bye.